Good evening, and many thanks for joining us here tonight at Nvidia. My name's Obi, and I'd like to share a few lessons from our own experience during our company's journey from a startup phase to what you can call a scale-up. So first, I'm going to talk very briefly about Nvidia and what Nvidia does, literally 30 seconds. And then I'm going to talk a little bit about the way our architecture has evolved and changed. So Nvidia is an online identity verification provider. In the simplest of terms, that means a user takes a photo of her identity document, a photo of her face or a selfie, and then we verify that she indeed is that person in the document. So that involves a lot of machine learning. We also have a sizable backend, a customer portal, some internal tooling, and a couple of mobile SDKs. So it's a lot of stuff to test. So now onto the architecture. So as is the case with many startups out there, Nvidia's code base and architecture have evolved in a rather winding and messy way. And naturally, this has had a profound impact on our approach to test engineering. So as every startup, it started off with an idea. And as we all know, one of the fastest ways of turning an idea into a working product is to turn it into a Ruby on Rails app. So there you go. You often start with this big pile of code, or a monolith, if you like. Right, so this is Nvidia at year 2. Our system literally consists just of this big pile of code right there. At year 1, pretty much the same situation. We still have this monolith there, maybe that little app over there. First half of year 2, things are still pretty much the same. People are still working within this big app here, and that small app over there. Maybe it's gotten bigger in the meantime. Now, something interesting happens in the second half of year 2. Not this. Quite the opposite is actually. There's a lot of flash, a lot of explosion. We're starting to realize that the monolith has its limitations, and we decided to gradually move into a microservice-oriented architecture. So, in case you haven't had a chance to work with microservices, they're essentially a bunch of small applications that together form a larger distributed application. So instead of in-process calls between different parts of the code, you have you communicate over HTTP. Now, each of those little apps has a specialized task to carry out, and this is supposed to make the entire system easier to comprehend, easier to scale up. If you're interested in the subject, 2 of our senior tech team members, Morgan and Paolo, have actually recently published a book on the subject called, I think, Microservices in Action. So yeah, enough about that. So we had this microservice explosion in year 2, and this is year 3. So as you can see, things are looking dramatically different now. Instead of those 2 apps that we had initially, now we have around 50 of them. And currently, at year 4 or 5, I'm not quite sure, our system consists of over 157 microservices. And they're carrying out various tasks. Some of them serve machine learning models, some do scheduling, some collect output from other services, some also talk to third-party providers, so there's a lot to test. So you might be thinking, all right, architecture, fine, but where does the testing come into all this? So this is where the story of the testing begins, basically at year 2. And we're in the dark ages. So we've got some unit testing, maybe some integration testing, a whole bunch of manual tests. So each time there's a release, all the devs stop working and start manually testing stuff. And these are often complex scenarios. You have to register, you have to submit a photo of your face, a photo of a document, maybe fill out some data in a form, it's very prone to human error, and it takes a lot of time. So this is the situation, and obviously all of that, not that great for scalability, and we're all about scalability. So you've got this monolith here, no test engineers. You really need to implement some kind of automated testing, and quickly. Or you also want to get a lot of confidence out of those tests. You want to know that your product is working. So what would you do? Seriously. Nice, yeah, definitely, and pay them. So that's essentially what we do. We hire some test engineers, actually one test engineer, who's sitting over there in the back. Hi, Christy. And so, yeah, and you also very likely go for some kind of E2E testing framework, or end-to-end. Automation testing framework, I should say. And that's because E2E testing gives you a lot of bang for your buck, theoretically. In our case, that framework was called Cucumber, which is one of the most popular frameworks out there. If you're test engineers, you probably know that word. So we hired our first test engineer who came in and started implementing Cucumber, and it really helped us a lot. So as we start automating the most important scenarios, developers suddenly have more time, we can release faster, and people start writing lots more code. So the code base starts expanding rapidly at this point. Awesome. It's really great. So we gradually grow the test team, and we arrive at a stage where we have over 100 Qs. That is even more impressive than I thought on the big screen. So the tests run in parallel, often on as much as 16 cores. So it really becomes a big, powerful system. Obviously, this system requires a lot of attention from the testers, and they want us to write more tests because they're awesome, right? They do all the nice things that I just named. So gradually, Tester and Cucumber become kind of almost one concept. They become very tightly coupled in people's heads. So this is roughly around the time that I joined Onfido, March 2018. And at that point, we are actively discussing a lot of issues that we keep running into with Cucumber. So the main issue is, if you remember from previous slides, we have tons of microservices. And what turns out is that E2E tests, so those big, long-running tests, and microservices often don't agree with each other. So what we're seeing a lot is that the tests are read most of the time. That means failed builds in Jenkins. And this is for different reasons. So those can be 500 errors, or some other related apps maybe undergoing deployment. Those can be caused by Cucumber dependencies. We also run into some input-output issues with credentials files. It's all kinds of stuff happening. And there are also many possible points of failure in a distributed app like that. So if the data passes through 10 different apps in one test, and the test comes out red, it's going to take you a lot of time to figure out where the test exactly failed. So we attempted to improve that situation, make it easier for people to use, make it easier for us maybe to debug. We looked around on the internet and implemented some of Martin Fowler's advice. Probably some of you know that name. We split the tests into reliable, so the tests that pass or fail quite reliably, we know why they do that. Flaky, those with unpredictable results, we don't know why they failed. And known bugs, so tests that kind of broke in a predictable way, we know what to do with them. And we only use the reliable tests while working on the broken ones in the background. So we basically make sure that the broken tests, the flaky tests, don't bother developers. We also Dockerize our Cucumber tests to make them easy to use for people. We made specific product teams look after specific parts of that big, scary app and certain groups of tests associated with those parts. But you know what? Nothing really helps. So the tests are still red. Devs keep ignoring those failing builds because there's a lot of flakiness going on. Okay. So, yeah, as you can see, some of the issues are, the tests are red all the time. The devs, they like learning stuff, but for some reason they're not that keen to learn Cucumber or BDD. They'd rather use something familiar like PyTest or RSpec or Mix for Elixir. It also causes some trouble for us because we are on product teams, but we feel kind of siloed away because we most of our time we just maintain the current system. There's a lot of work to be done on it, and that means we got no time to research new testing tech and make other people's lives easier. So what we agree on is we actually do take time to research new stuff. So we go back on Papa Fowler's website and we find this nice idea of a test honeycomb. So basically, you probably all know the concept of test pyramid, right? So you got a couple E2E tests right here, then you got a bigger number of integration tests, there's mid-level tests, and you got a whole bunch of unit tests. That's a universal prescription of how you should structure your test and test suite, right? But it turns out that with microservices, you get a lot more bang for your buck out of integration tests. They give you a lot of confidence, but they're also easy to write, they run quickly, and they're very applicable to those moving parts or static parts, parts of a distributed application. So if you see a contract or component test fail, you know exactly in which app it failed. It makes debugging almost a pleasure. So yeah, we start reading up on component testing or service testing. This bit are basically tests that kind of treat your little app microservice as a black box and just send HTTP requests to it and assert that the response from that service is what you expect. So this is quite nice. If you send a request to it, if you get back something you didn't expect, you know there's something wrong with that app. As compared to that approach where we had cucumbers in that chain of 10 apps that we don't know where things failed. And a second component to this are contract tests, which basically allow us to make sure that if one app assumes something about another microservice, this will be published, and that other service will be able to access that contract, and whenever it breaks it, they can't deploy. So sometimes we have apps maintained by different teams, and one team makes a change. So that's a common problem with microservices, right? You have tons of apps maintained by different teams in your company, and one of those teams changes something, and in your stubs, you still assume that that app works in a certain way, but it doesn't anymore. So this is a way for you to prevent other teams from introducing breaking changes to services that your service depends on. After the research phase, we decided to implement some proofs of concept, POCs. We did first in Elixir of all languages. I don't know why, but it was cool. Then Python and Ruby. So what were the results of all that? What we noticed is that we're getting more collaboration with developers. The devs are happy because the tests are suddenly easier to understand. You can just run them with PyTest or RSpec or whatever test framework you're using normally for unit tests. They get faster feedback. And it also means more meaningful test work for us because, to be honest, working on component and contract tests is quite cool. It's quite fun to do. So all in all, it was a very positive transition for us. And I know this might have been a little bit quick, so just some conclusions in terms of what we'd like you to take away from this talk today. So if you're a founder, if you're a startup founder, if you're about to start a business, hire a tester early on, because it's always a bit of a problem when testing has to catch up to the code, and this will slow down your developers and make your product grow slower. You can even go for a contractor if you like, right? And just make sure some testing infrastructure is in place right out the gate. Right. Second thing is communicate your vision for scalability early on, because this will help the test person understand what kind of test framework they want to go for. So, for example, Cucumber is a beautiful tool. Like it's a fantastic thing, right? The guys who invented it are amazing. If you plan mostly on working with a monolith, or if your product managers love BBD for some reason, it's still an excellent choice. But if you plan to use microservices, this will have a major impact on your choice of a testing framework. And just bear in mind that testing should never be a big problem. It should be relatively smooth to carry out and easily understandable to anyone on the tech team. If it's not, you'll risk putting your test team in a box, in a silo, which will damage communication and ultimately impair your ability to scale quickly. Okay, and if you're a tester, maybe you can also learn something from our story. So first of all, do check out service level testing. First of all, quite fun to learn. Second of all, you grow as a developer. And third of all, it can really bring a ton of value to your company. So, yeah, and another thing is, this is, by the way, all very subjective, right? You may totally disagree. This is just me rambling. So as test engineers, we're very vulnerable to our time and attention being used quite liberally by others. If you're a test engineer, you might know what I'm talking about. So without the time to do focused work and research, we won't be able to discover a lot of the cool stuff that makes other people's lives easier. So yeah, value your time and protect it like they're paying you for it. And lastly, and that's been a big one for us, if you notice your collaboration with developers starting to grind to a halt, stop for a moment and try to figure out why. Because we're not doing companies any favors by being shy. If you notice you're getting siloed away, it's basically your responsibility to act. As test engineers, I guess we owe it to ourselves to have awesome, stimulating careers. So that's it from me, basically.